Hello and welcome to this second video on the NCS 5500 route scale. My name is Nicolas and I'm part of the technical marketing team in Cisco's Service Provider Business Unit. Last time, we presented you how it's possible to store a full v4 and v6 Internet table in NCS 5500 systems, not using external eTCAM. And you can check the video clicking here. Today, we will present you a situation where you need even larger routing tables. And that's the purpose of the system based on Jericho forwarding ASIC with external eTCAM. It's an external memory that offers up to 2 million extra v4 entries. We'll detail the logic used to sort the route between the different internal and external resources. And this with concrete, real-life examples. Let's get started. We have seen many use cases where very large routing tables are required. First, we need to support the full view, v4 and v6. You will get different answers depending on who you ask, but it's common to receive 700,000 v4 routes and 65 to 70,000 v6 prefixes from your transit providers. Second, you will have your peering routes. The routes you're going to receive from your partners will be more specific than the one present on the internet, and you can add dozens of thousands of routes to your table. Third, you have your IGP routes, ISIS and OSPF. It will depend on the size of your network, the number of routers and links you have, the way you manage your areas. 4. It's not unusual to see a lot of host routes in the network. They are advertised by DDoS mitigation systems, or they are present because you are doing a lot of virtual machine migration. And I've seen network with multiple times hundreds of thousands of /32 routes in the table. Finally, Internet is constantly growing, and we've seen that in the former video. We expect the routers today to be able to support the size of Internet in 10 years. All these reasons justify the use of systems based on external eTCAM to accommodate today's and tomorrow's requirements. For this demo, we will use NCS 5508 chassis with 24 by 100 gig line cards. These line cards are based on Jericho ASICs with external eTCAM. The operating system is sorting the routes based on address family and prefix length. In the former video, we detailed the specifics of the internal memories. LEM is capable of 768,000 entries, and LPM is algorithmic, and the size will depend on the prefix distribution. Today, we introduce the external eTCAM, capable of 2 million v4 entries. In 623, these 2 million entries are split in 20% for access list and 80% for IPv4 routes. But this default carving can be changed with configuration. Now let's take IPv4 routes. The /32 will go in LEM and the rest will go in external eTCAM. For IPv6 prefixes, the /48 will go in LEM and the rest will go in LPM. To put things differently, in LEM you will find your /32 IPv4 entries and your /48 IPv6 entries. Also, you will find MPLS and MAC address information. The LPM, you will find your IPv6 route aside the /48 and the multicast entries. Finally, in the external eTCAM, you will find your IPv4 routes aside the /32 and access list entries. Let's illustrate all this with a real use case. First, take a look at the chassis. In slots 6 and 7, you will find 24 by 100 gig line cards with external eTCAM. A show route summary and show route IPv6 unicast summary will give you an idea of the size of the tables, v4 and v6. You have 1.2 million v4 prefixes and 63,000 v6 prefixes, mostly coming from BGP. A show DPA resource IP route and IP6 route is a very useful command to identify the way we are distributing the prefixes in terms of prefix length. Interesting to notice, we have 436,000 /32 v4 host routes. And we will repeat the same operation for IPv6. We see this time that the /48 is the largest population, and we have 21,000 of them. The show controller NPU resource will display the utilization of the different databases internally and externally. We use 58% of LEM, 9% of LPM, and 48% of external eTCAM. More specific to the external eTCAM, you can use show controller NPU X eTCAM to take a look at the carving and utilization. We can use Grafana to visualize the same information streamed by telemetry. Let's project ourselves in the future and see what will be internet size in 2025. It's certainly not a very rigorous approach. We picked the last couple of years and we identify what was the growth for each prefix length, and we derive this information to the future. So let's say it's an approximation of what internet will be in 8 years from now. We configured these projected new routes and advertise them to the same router we use in former test. Total represent 1.6 million IPv4 prefixes and 108 IPv6 routes. Now the question will be, how much does it represent in our different memories? It will be 62% of the LEM, split in IPv4 and IPv6 prefixes. It's 12% of the LPM, with only IPv6 entries. And it's 72% of the external eTCAM v4. So we have still quite a lot of empty space with a super large amount of host routes and the 2025 projected internet size. To conclude this video, we've seen that we have situations where we're gonna need very large routing tables today and certainly tomorrow. With the NCS 5500 portfolio, we have routers and line cards in chassis using Jericho chipset and external eTCAM. This external eTCAM will offer 2 million extra entries. Total 3 million routes. So we can accommodate today's and tomorrow's needs with these systems. In the next video, we'll show you how we can mix base and scale line cards inside the same chassis. Thanks for watching.